Okay, let's give you guys some more practice. So similar to the previous video, we're gonna fix the perimeter of this rectangle, but this time we're gonna create a cylinder by sweeping through 360. Okay, so we're gonna sweep through, rotate this through 360 and create a cylinder. So given a fixed perimeter, how should I arrange X and Y so that it will give me the biggest volume for this cylinder? Okay, and remember, I don't always have to give you the perimeter, and I don't always have to give you the volume. If you want the perimeter, then create the variable yourself. If you want to create the volume, well, the question is, how do I maximize the volume? Well, how should I arrange X and Y so that I will have the maximum volume here? Okay, so press pause and have a go. Okay, so similar to the previous one, let's just set up the variable p for the perimeter. So let's just say the perimeter is p for the time being. So this is our constraint here, and the volume is given by this. Okay, because well, if you look at the cylinder here, if you look at the cylinder, well, if you look at the cylinder, hang on. If you look at the cylinder here, the volume of this cylinder is given by well, you need the area here, pi r squared, but r in this case happens to be x. So the area of this circle will be pi x squared, and then you need to times by the height. Well, the height in this case is y, so the volume will be pi x squared times y. Okay, it's actually simpler than in the previous video. So anyway, the perimeter is given by this. We just set up the variable p. Later on, it would just disappear. Okay, so set up the variable p for the perimeter. So the perimeter is fixed, and then the volume is given by this. Now looking at now use implicit differentiation now. So this will then become this, because remember p is fixed, and we are varying x. We are varying x, so y here is a function of x. Okay, so when you differentiate this, p is a constant, it will give you 0. Differentiate this with respect to x, that will then be 2. Now differentiate this with respect to x will give you 2. Because y is a function of x, it will give you dy by dx. Okay, rearrange this, and then dy by dx equals -1. Now looking back at this, looking back at the volume here. Okay, looking back at the volume here, we need to differentiate this. So that will then become this. And don't forget, v, the volume, is a function of x. So when you differentiate, we now need to differentiate this with respect to x. So differentiate this with respect to x will give you this. Now here you've got to visualize this as, you've got to use the product rule here. So differentiate this, leave this the same. That will then give you this. Okay, and then leave this the same, and then differentiate this. That will then give you this. And then earlier, remember, dy by dx is -1. Okay, earlier dy by dx equals -1. So you can put -1 into here. Put -1 into here. That will then give you this. Okay, and then now, so this is like this is like having a graph of volume versus x. So we want to find, so I don't know what it looks like, but then we want to know where the gradient will be 0 here. So we set this to be 0. So this will then become this. Okay, so when you get to this stage, don't forget you've buried the constraint in here, meaning the perimeter is fixed. You've buried the gradient being 0 is taken care of inside here. When you get to this stage here, you've taken care of the perimeter, and you've taken care of the gradient being 0. Okay, so now rearrange it. So here you've got one block, taking away this block, add this block to both sides. That will then give you this, and then divide both sides by x. That will then give you that. Divide both sides by pi. That will then give you this. So what that means, well, when you get to this stage here, what it means is, if you want to maximize your volume here, then create x to be twice the length of y. Okay, then that will give you the maximum volume. Okay, looking so here you can compare the two now. This triangle here, sorry, this rectangle here is the same perimeter as this one here. But the thing is, you can see that the volume here is the volume of this is much bigger than the volume of this. You see, if you looking at this here, if you make this length to be twice the length of the height here, then you're going to get the maximum volume. If you look at this this rectangle here, this is not twice the length of this. So look at the difference in the two volumes here. This one here seems to be a lot bigger than this one here. Okay, so if you want to maximize the volume, then make this length to be twice the length of this. Okay.